Okay, we're going to start today talking about mirrors. We're going to talk about flat mirrors, we're going to talk about curved mirrors, and just kind of see where we go. We're going to try to get most of this done on mirrors fairly quickly, so if you need to pause and draw and stop, that's great. I would suggest you do that. First off, we're going to talk about flat mirrors because they're kind of the simplest. That's a flat mirror right there, and this is a little laser pointer. So if I shine that at it, you might be able to see the little red dot right there. Hang on. That little red dot right there is where the laser is coming and hitting and then bouncing back up. And so what's happening is we have something called angle of incident and angle reflection. If we draw a line that's perpendicular, remember what we call those perpendicular lines? Called normal. And then we take a look at how the light's coming out of the laser. We use red since it's a red laser. And it's coming down and hitting that normal line, okay? Or it's hitting the point on the mirror right there where that normal line's sitting, okay? You just measure normal from where it hits and intersects. So here's the laser that's coming out of. That angle right there is called the angle of incidence. And you can hear my assistant in the background there. Macy's with me this morning. Okay, that angle's always going to be equal to the angle of reflection. The angle that it bounces off at. Okay? That is the angle of reflection. Because light travels in a straight line, it's always going to follow a path like that. And our brain expects that. Okay? Mirrors work off of that principle. So if we had a flat mirror, say that this is a flat mirror right here, and we have an object in front of it, like it's a person or something like that, and he's standing there, what's going to happen is this object right here is going to appear as an image in the back of the mirror. Okay, a virtual image is what that's called. It's virtual because it's not really back here. What this person's going to see is light coming from here and bouncing back. So it appears it comes from back here because our brain says it travels in a straight line. The mirror's kind of tricking the brain. Okay, if you're like me, you've always wondered, you know, how far behind the mirror do you appear to be, all that? Well, it's exactly the same. It appears to be the same distance if it's just a mirror like this, okay? If it's a flat mirror. So what happens is, you can kind of, if you take the distance you are from that mirror, you can set up another hash back here, and that's 2 inches, okay? And so I'm going to make a point right there that tells me kind of where that's going to bisect, okay? If he's seeing his whole person there, that's kind of what you do. And you say, okay, well from right here, the bottom of the arrow would hit there and bounce back. And that's what this person's going to experience. His eyes, assuming are up here, he'd be able to see his feet down here looking like that, okay? As long as the mirror is big enough to cover that. But what appears to happen is it looks like that light is coming from here, okay? And he would appear to be the same height, so I draw the same size there, okay? And so if he were looking from down here, that light would appear to come like this, okay? And we draw these dashed lines to show a virtual image. These are where the rays look like, but they're not real. So that object looks like it's virtual, upright, and same size. Okay? Alright, I'm going to pause here for a minute, take care of Macy for just a second, and then we'll do some curved mirrors. Okay? Alright.